Hello friends, so today we will be studying 555 timer as an astable multivibrator. So this topic is very important for students doing electrical engineering, instrumentation engineering and electronics engineering and other sister branches. So in a 555 timer, this is the circuit diagram. My basic concern is not to delve into the internal circuit, but simply to show that this kind of waveform produces a square waveform as an output. This is the basic concept of 555 timer as an astable multivibrator. In a 555 timer, there are two resistances RB and RA. So you can see there are 8 pins 8, 4. I'm not telling it in random order: 3, 4, 1, 2, 6, 7. This is the output, and this is the on state, and this is the off state, and this is the on state, and this is the off state, this is the on state, and the process goes on when time is plotted, or you can say output voltage is plotted against time. This is the input waveform, this is the output waveform, you have to remember. So the output voltage here, this is the on state. Now you know that any electronic circuit works on zeros and ones. So this on state means a high state or one state, and off state means low state or zero state. So let me go into the theory first. Okay, so what is an astable? You can see an astable multivibrator is often called a free running multivibrator. Is a rectangular wave generating circuit. So as I already told you that when we apply this as an input, it produces a rectangular wave. An astable vibrator is often called free running multivibrator, is a rectangular wave generating circuit. The circuit does not require any external trigger to change the state of the output. So in class 12 you might have been aware of a fact that mutual induction, although they are not quite interrelated, but the concept is the same as mutual induction. What happens in mutual induction is that once you supply the input, then further you don't have to supply the input again to get an output or a feedback. I mean to say that the circuit does not require external trigger. That I mean to say that once triggering is done, then no external triggering is required to change the state of output. Hence the name free running. That is why it is called free running. It is often called a free running multivibrator. However, the time during which the output is either high or low is determined by two resistors and a capacitor. However, the time during which the output is either high or low is determined by two resistors and a capacitor. Now you can see there are two resistors and there are two capacitors. So these things determine the time during which the output will remain on or off, high or low. On means high, off means low. See, one more thing you need to know is that when you give input, this is the charging time, this is the discharging time, this is the charging time, this is the discharging time, this is the charging time. Okay, the charging time, the voltage charges from 1/3 VCC to 2/3 VCC, and discharging again 2/3 to 1/3 VCC. This is called the charging time, or you can see here this is a charging time, and this is the discharging time. Okay, so hence the capacitor is externally connected to the 555 timer. Okay, as shown in the figure, the capacitor is periodically charged and discharged between 2/3 VCC and 1/3 VCC respectively. The time during which the capacitor charges from 1/3 to 2/3 VCC is equal to the time during which the capacitor is high and is given by TC equal to 0.69 RA plus 2 RB. So the time during which the time during which the capacitor charges is given by charges from, it goes from low position to high position. Capacitor is given by is given by TC. So TC is 0.69 RA plus RB into C. So you have to remember this expression where RA and RB are in ohm because the unit of resistance is in ohm and C is in farad. Similarly, the time during which the capacitor discharges from 1 to 3 VCC to 1 by 3 VCC, during which the output is low. So when this output is low, the capacitor discharges from 2 by 3 VCC. 2 by 3 means 0.66 and 1 to 1 by 3. So you can see this, if the capacitor charges, then the voltage increases, and discharges, then the voltage decreases. Similarly, the time during which the capacitor charges is this one. Okay, TD is equal to 0.69 RB into C, where RB is in ohm and C is in farad. Same. So the total time period of the waveform is obtained by adding charging and discharging. You can see this is the charging time and this is the discharging time. So the total time period is obtained by T equal to T. This is T equal to TC plus TD. Okay, so if you add these values, take 0.69 common, then you'll get RA plus RB plus RB. That means RA plus 2 RB into C. You can remember RBC as red blood cells. I think this will be the best way to remember TD. Okay, so the if you add them, you get 0.69 equal to RA plus 2 RB into C. The frequency of oscillation is now, so I have calculated from the things that I have learned in 555 timer is that this is the circuit diagram I have learned. It consists of 8 pins, 2 resistances, 2 capacitances. This is the input waveform, this is the charging time, this is the discharging time, and on x-axis we have T time plotted against output voltage, and it charges from 1 by 3 to 2 by 3 and discharges from this to this. Okay, and you know that it is free running. So we have learned charging time, discharging time, and total time. Now the frequency of oscillation of this 555 timer would be given by f0 equal to 1 by t. So frequency is inverse of time. We all know that sometimes it is denoted by mu, which is equal to 1 by 0.69. You put these values here, 1 by 0. It's not that difficult calculation. RA plus 2 RB into C. So 1 by 0.69, if you put these values on your calculator or you simply calculate, you will get 1.45, and RA plus 2 RBC is as it is. So this is the expression for frequency of oscillation. Isn't this easy? So now last thing that remains is that duty cycle of the astable multivibrator. Now we calculate the duty cycle. So you calculate the duty cycle is used in conjunction with the astable multivibrator. So whenever this line means that whenever anyone talks about the 555 timer as an astable multivibrator, duty cycle is another word that comes into mind. So the duty cycle is simply the ratio of charging time divided by total time, and the total time was given by charging plus discharging time. So if you take this TC below, so you'll get TC plus TD, 1 by TC plus TD divided by TC. So we don't need that expression, but I'm just telling you that duty cycle is TC divided by total time, charging time divided by charging plus discharging. You remember T on divided by T on plus T off, so you can correlate this for expression with that. So if you put these values, TC is 0.69 RA plus RB into C, so you will be getting these values. Okay, remember RBC is red blood cells. Okay, an easy way to remember it. And the total time would be TC plus TD, and TC plus TD would be 0.69 RA plus 2 RB into C. This is the below value. You put these values here, so you can cancel this, but that's not sacrosanct into you finally you get this value into 100. You multiply the whole value into 100, and finally this is the expression for duty cycle. So today we have learned many things about 555 timer, the output waveform, the input waveform. We calculated frequency of oscillation, we calculated duty cycle, and we calculated charging time and discharging time, and how it depends, and how does the curve look like, and what is the total time, how many pins it has. Let us look at the pins. One, this second pin, third, fourth, 5th, 6th, 7th and 8th. So these pins have the individual, this is the VCC supply voltage, this RA plus 2 resistances, we have 2 capacitance you all know it stores charge. So finally we come to the end of this video. Thank you.